Hello there, this is Marwan. Today we will be doing a finite element analysis on a module which is a bike track. So in this model, we will be seeing how to use ANSYS. Like this is basic, really basic, and we will apply some forces and we'll see how our module deform and how to know what are the stress distribution in our module. So let's get to it. First of all, let me show you our interesting problem, which is a real life problem. So as you can see, the bike here, and this is our crank. Okay. So also we have another more detailed picture, which you can see our module. So this is after we made the geometry. So you can do your geometry using any CAD software. Like ANSYS can accept geometry from any software, but you have to convert the file uh, to the type x_t. Then you can import it directly into ANSYS, and I will show you how to do that in a while. So this is our geometry, and we can see here these 3 points will be fixed. They will work as a fixed support. So let's imagine it as if we take a snap of that bike, of that crank. Okay, and there will be a load here, and let's assume this load is 100 pound force. So this is basically our geometry. It is easy, and we will do a 3D analysis of that. So let's move to ANSYS, and here is ANSYS. I mean, if you install ANSYS and you open it, you will see this this screen in front of you. So on the left side, you have so many things you can choose from. So you have electric, you have fluid dynamics, you have all the way through transient thermal, but we are interested in static structure since our problem is in that field. So we will drag static structure and drop it in the green box here. Let's give it some time. Okay, here we go. So we have this static structure. Let's just rename it. I will name it bike crank. Okay, bike. There we go. So here we have the engineering data first. Okay, so in our crank, the material that we will be using is aluminum, 6061 T6 alloy, and the Young's modulus for that is 1 multiplied by 10 to the 7th psi, and Poisson's ratio is 0.33. So how can we define our material? I mean, if you module your geometry using SolidWorks, for example, and you choose the material in SolidWorks, when you import your geometry in ANSYS, the material will be different. The material will not be as the one you used in SolidWorks or you assign in SolidWorks. I will show you what is the default material in ANSYS and how to change it. So engineering data, if you double click in this, and I will do this in later steps, if you double click in this, you can choose, or you can choose your materials parameters. So I cannot just go there and choose aluminum, but I can define its Young's modulus and its Poisson's ratio. Let's move to the geometry. So as you can see here, the geometry you can, as I said, you can import your geometry if it's ready with you, or you can double click on geometry and this will open something called designed modular, and this is implemented in ANSYS, where you can design your own module with ANSYS. But I will import my geometry. So if I right click on this, I will say import geometry, and I have my geometry here, which is crank geometry. Okay. So whenever you see a green tick beside anything in ANSYS, that means it is ready to go. So I will go to module, and I will double click on module. Okay. So as you can see here in the bottom left, it says starting mechanical, and in this mechanical, we will define our mesh, and we will find our solutions. We will apply the forces and all the parameters for our problem. So let's see how it goes. Okay, here we go. It's opened ANSYS mechanical. It takes some time. I know it's boring sometimes, but let's hope it opens quickly. Okay. So it imported our geometry here. As you can see, this is our geometry. We can play with it. We can, for example, choose rotate and rotate our module. So you can see it clearly. We can also zoom in using this button. So you can zoom in our geometry. Okay, so let's move to something more interesting. Let's move to the mesh. So whenever you import your geometry, the first thing to do is either you assign your materials or you do the mesh. So I will do the mesh first. So I will right click on mesh. Then I want to see what is the default mesh first. Maybe we need some modification on the mesh. Maybe there is some inequality in the elements. We need to modify them. But first of all, we need to see what is the default mesh looks like. Okay, I'll say generate. Okay, so here is our mesh ready to go. By the way, you can work with this mesh, but for me, I see it needs some modification. So it's so clear that this mesh is not, it doesn't look appropriate. So if I can zoom inside this hole here, okay, if you can see this face, this face here, it's not really uniform. Okay, so how to know if your mesh is of high quality or low quality? You will go to mesh in this panel, then you'll go to quality and click on the plus. Then if you choose mesh metric, it's shown here none, but we want to see how much is the skewness. Skewness, by the way, is it tells you how much your elements deviate from the perfect perfect shape or the perfect. Okay, so we can see here. So I can change this like this. I will put it in here. So as you can see here, a lot of our elements are not so if it is 0, this means it is most accurate or it is most preferable. So you can see here the maximum number of elements is around 0.7, and this is not high quality elements. So let's play with the elements. Let's play with the size of the elements. Let's play with the shape of the element. Maybe we can get something more, something of high quality. Okay, so I will close this here. So as you can see our mesh, symmetric, show skewness. Okay. Then I will choose mesh metric or display, metric display, then I'll choose none. If I come here and I choose none, then it will return to the original mesh. So in this, what we can do to have higher quality mesh. And then we will see the difference in the skewness shape or in the skewness diagram. There will be a huge difference. So I will click on mesh, then I will go to, first of all, if you can see in the top panel here, let's say, so the mesh metric, let's say sizing, for example. I will say sizing. Okay, so for the size, I will choose, this is 0.44312. I will choose, first of all, we need to identify the geometry. What faces are you sizing? What body are you sizing? So I will choose geometry. Then from the top, you can choose entire body. I will choose the whole body and say apply. Okay. Then I will choose the size that I want, which is, let's say 0.2, for example, 0.2 inches. And by the way, I'm using ANSYS student version, where I have a limited number of elements, which is, I guess, 32,000 number of elements. So for this, I don't want to make my mesh, my element sizes too small. Maybe I will run over 32,000. Okay. We can choose this quadratic or program control. So it will be quadratic, I think. So we don't need to mess with that. I will choose, so we sized the body, or we sized, we did body sizing for our module. Then I will use something called multi-zone. But in the multi-zone, you can change the shape. As you can see here, these triangles are not preferable. So let's make them cubic shapes. For this, you can choose method. Method, you can select what are the faces, what are the bodies you want to apply this method on. So I will choose the entire body. Then I will say apply. Okay. For the method, it says here it is written automatic. I don't want it to be automatic. Well, I will use multi-zone. Okay. Then I will use hexa. That's good. And program control, I will use uniform. Okay, so this will give me a uniform shape of that element sizes. Then I will say generate. And let's see, after this, I will apply skewness, or I will see how does the quality of my elements look like. So let's say generate or update, whatever you like. Let's wait for it. Okay. Now you see our elements shapes became different than before. I think this is more uniform. Okay. So let's look how the skewness or how our mesh quality deviates. Okay. From the perfect shape of the elements. So I will say again mesh, then I will go for, by the way, if you want to know how much how much your elements or how many your elements are. You can go to statics and see your elements is, so here my elements is 968 elements, and the nodes are 5,728. So I'll go ahead again to quality. Oh, it's open already. I will use same thing. I will use skewness, as you can see. You see, in the older one, we saw a red light. That was scary a little bit. So, but this one is a little purple, and you see that the deviation. Before, there were the majority were here, away from the perfect element size. But now we have a better shape, and we always want the shape looks like this. So it's decreasing, not increasing. And you see this is near zero. Okay. And if you choose, for example, I want to see what are these elements, for example, that are concentrated here. So I will click on this, then I will use geometry, and I can see those elements. So the least quality elements will be in this side, okay, away from the zero. So if I click on this, and you can see how many elements are there. So these are only 5 elements, and these are 225 elements. Okay, and they are almost zero. You can see the value. They're almost zero. So they are almost perfect. Okay, so I will click on these 5 elements and see where are those 5 elements. Maybe I can make it better. Maybe I can do something that makes it less than 5 elements, or makes these 5 elements near to the perfect element shape. So as you can see here, these are our 5 elements. So let's try our best to make them less than this. Maybe we can't. Maybe we can, but let's do our best to make it almost perfect. Okay, so I'll go to mesh. Again, let me pause this. Okay, I will choose none. Okay. So as I said, we will have these 3 phases as fixed supports, and there will be a force inside in this phase. Let me choose the phase. Okay, in this phase, there will be an upward force of a value of 100 pound, and these 3 phases will be fixed. So I will do that later in the mechanical. Sorry for that. Okay. So I will zoom in on this. As you can see, these 3 phases will be fixed. So it will be better if we make the elements in the fixed support or in the fixed phases, if we make them smaller. So there will be a higher quality solution. So I will do that now. I will choose mesh. And this will show how to make, if I want, for example, if I have let's say a fillet in a pipe or in the end of the pipe. Of course, we want the elements to be more, so that we can have more accurate solution. So how to do that? First, it's pretty easy. So I will choose mesh, then I will go to sizing as we did in the first, but here I will choose those 3 phases. So let's say cancel, okay? Then I will choose, for example, this phase, okay, geometry, this one, and this one, and this one. So it is, then I will click apply. So as you see here, 3 phases, and this is phase sizing, not body sizing. Then, for the sake of answer, I will also do face sizing on those faces where our force is applied. Okay, so I will delete this. Okay, because it's not working. I will delete it and do it again. Okay, yes, delete. Okay, do sizing, geometry. I will choose here. I choose the face, and I will choose this one. Okay, we have a problem here. So I choose those three phases as well as. Okay, this is the problem I was facing. So let's say single select. I don't want it to select because if I said box select, if I did this box, every face inside this box, like fully inside this box, will be selected. Okay, I will choose for the mode. I will choose single select to be more accurate. I will choose this face and this face and this face as well. Okay, let me choose this one as well. I will move to the second, to the next end. Oops. So moving there, I will choose those three faces as well. So single select, okay. These three faces. I think I missed previous one. So let's go back to. Okay. I'll select those phases as well. Okay. And say apply. So we applied it on those 7 phases. Let me get this. Okay. It's pretty nice. So what is the size that I wanted to be applied on every element inside of these phases? Okay, let's say I want it to be 0. For example, 25 inches. Let's say 0.125. Okay. So if I say mesh and go and zoom in, I can see uh, how much how the sizes looks like. Okay. Then I will do generate or update mesh. This will update our mesh. Okay. So as you can see here, the elements inside these faces has become of more elements. Then I will go to statics, and I'll have 2,142 elements and 11,552 nodes. So let's go to quality again, and let me choose skewness. So let's see how much. Okay, so previously we had a bigger value than this. Okay, I will check. Okay. Okay, I will check on this and say geometry. Then I can see what are the elements that are sitting in. So if you can see this, these are really small. So this value is even smaller than the value that was here in the previous schemes. Okay. So now we have a less we have a better or high quality elements. Something more to see or to check is that the element quality as well. So as you can see, our elements are of high quality. We have 6 elements. So each element that is, or which element is near the value of 1 will be of high quality or will be perfect. Okay. So you have nice distribution in here. So I will close this. And now let's move to static structure, or where we can, okay, so whenever you finish, just close the mesh metric or say none. So I'll click none. Then I'll move to static structure. So here, what are we going to do here? We are going to apply our load. We are going to apply, or to say, look, ANSYS, we have fixed supports in here and here and here, and we have a load, an upward load in this direction and in that phase. You can also apply pressure and other interesting things. Okay. So I will apply my, first of all, I will choose my fixed supports, or I will identify my fixed support. So if I go up here and say fixed, this is under supports. So I'll choose fixed, and I will choose my my faces where I have a fixed support. Let me just, okay, I have this face. Then I will choose this face and this face and this face as well. I will apply. So now ANSYS knows that we have fixed support on all of these faces. We have also to apply our force. So you'll choose force. And so we have to identify our force, or where our force is applied on. So I will choose the inside face, which is this face. Okay. Then I will say apply. Then I need to identify the direction of that force. So instead of vector, I will use components where I can identify how much my force is along the x-axis and how much is it along the y-axis, and as well as along the z-axis. So my force is, of course, so it is upward, and we have this coordinate system, so it will be along the y-axis. So I will say 100 ground force along the y direction, and now you can see this small arrow that shows my force direction, and these little red lines shows where the force is applied on. This is pretty nice. Now let's move. Let's get back for a little, and let's define our material. So I think now our problem is ready to be solved. We have set our mesh. We have modified our element sizes. We have as well applied our force, and we have identified our fixed supports. So I'll go back a little to my workbench, and I will double click on engineering data. So as you can see here, the default material in ANSYS is structural steel, and you can see its properties here. So I will choose, I want to set a new material for ANSYS. This is a new material for ANSYS, which is aluminum, and I already have its Young's modulus and Poisson's ratio. I will say aluminum. Okay. Let's say aluminum 6061 T6 alloy. Okay, then I will click on it. So for our material, it is under isotropic elasticity. So I will drag isotropic elasticity and drop it on the material box. Now it's dropped. Now I will choose my Young's modulus and my Poisson's ratio. My Young's modulus is 1 e or 1 multiplied by 10 to the power 7, then plus 7. Okay, and my Poisson's ratio is 0.33. Okay, this is pretty cool. Okay, for the Young's modulus, I have it in PSI, not Pascal. So I'll choose PSI. Okay, and I will change this again. So it is 1e plus 7. Okay, now we are pretty cool. So I will go back to project. Okay, and I will say in the module, I will say refresh model. On the setup, I will say as well refresh. So it's refreshed. Okay, I will click on double click on setup. And here I need to assign my material. So in materials, I have aluminum alloy. So I will choose this material. Okay. Instead of structural steel. If you're not sure if this material is the one used or not, so you can just say refresh materials and then choose your material, which is aluminum steel. Okay. So for aluminum steel, we need to create material assignment. Okay. So for this, I will choose the entire body. Say okay. So this has assigned aluminum alloy to our whole body. This is pretty cool. Now we are done with everything. We just need to find the results. So for the results, let's go to solution. In the solution, I will choose what are the values that I want to get, what are the results that I want to see. So of course, we want to know how much our model deformed. So I will say total deformation, as well as I want to know the stress. So I'll say, let's say the equivalent stress, and as well as, for example, the normal stress. So for the normal stress, it will be in the x-axis. We can change the orientation. We can make it in the y or in the z-axis. I will leave it in the x-axis. Then I will say solve. So now you can click on solution information, and you will see all the information for your solution. As you can see, these are the information for the solution. Okay. So now let's go to our solution and see how to interpret those values. I will click on total information, and you can see these pretty cool colors here. Okay, so these values are predictable because we have the most deformation will be on the right side. Okay, and the least will be around the fixed supports. You can change. Or you can increase the colors, so it will be maybe clearer for you. So see, say Just click on those colors and then click on plus as many as you want, and you can see and you can know how your body deforms. So the most deformation will be in the red, along the red color, and the least deformed element will be along the blue color, as you can see here. And this deformation will be, of course, in inches. Okay. So what if you want to see how your body deforms? Like if you want to see it deform, then you need to just let me increase this. Okay, and say play this, and you will see it deform, and you will see how does it deforms. You can also save this. You can save this clip from here. Say export video file, then you can save it wherever you want. Okay, so this is pretty cool to see it deforms. Okay, you can also, this is the auto scale, not the actual. So this is the true scale. I mean, for the common sense, this will not be the real deformation. I mean, no back ranks deforms like this, but this is just to illustrate how it will looks like uh, in what direction and all that stuff. So if I see true scale, you won't see the same interesting video. So just a little change. Okay. There is something interesting as well. So I will say that. Shows this. You can say, you can even deform it. You can even see it how if even if the auto scale is not showing, for example, the direction or how this body will deform. You can also choose 2x auto, which is 2 multiplies by the auto scale. So let's see how it goes. Okay, you can also increase it more. So 43. Okay. So I will leave it at auto. You can also play with the colors and with the edges. So for the contours, as for example, you can say smooth contours. Okay. For the edges, you can say no wireframe, or you can see only the color. It is pretty smooth. You can choose, for example, show elements. Okay, as well as you can tell ANSYS to show the real or the undeformed wireframe. Show undeformed wireframe, so it will show you the undeformed one. Okay. So what if you want to know? Let me just. I like it to be with the edges, so I will say show elements. Okay. And contour angles, or let's say smooth contours. Okay. So what if you want to know the deformation at an exact location? You can just choose crop, and so if you, for example, if I want to know the deformation in this particular point, for example, so I'll just click on it. I will give, and it will give me how much the deformation there. So what if I wanted to know the maximum? Just click on the maximum. It will show you the maximum is here. And of course, you can see the maximum result on the left numbers here. Then let's move to the equivalent stresses and see how much those stresses looks like. Double click on maximum, show it goes away. So here is the maximum stresses, and this calls for traction and contraction as well. So we have here the maximum stresses will be in the middle, as you can see, and the least stresses will be uh, on the sides. Okay. You can also do the same. You can crop the values, and for example, I want to see what's the maximum. So it will tell me that the maximum is here. You can just click on it, or you can see the maximum in the left one, in the left little cubes here. So it says it is 15,322. Okay. PSI. You can see the units are here. So unit is PSI. You can see the type. You can also save this picture. Okay. Then I will go to normal stresses, and I want to see, and here I want to see the normal stresses along the x-axis. So now we have the normal stress along the x-axis. Okay. You can always see how the solutions will occur. Like for example, the equivalent stresses. I can choose just to play, and it will show me how those stresses uh, will occur in the model. For example, the normal stresses, I can do the same. Okay. So the blue and the normal stresses. The blue is for contraction, and the red is for attraction. But these actually are the same values because they are in the middle, and our body is almost symmetrical. If we take a line along the path I'm going for, this will be a symmetry line. Okay. We can also add in our static structure, or we can also add pressure from here. We can add heat as well. We can add so many things. Okay. This almost finalize this session. I hope it was a great session. And there is something. What if I want to know uh, the stresses along a line, for example? What if I want to know the stresses along a path? So I will go to geometry, or let's go to coordinate systems. Okay, I will say plus. For example, I will choose or let's go for the module, and let's say construction geometry, for example. Then let's choose path. Okay. So then you can define your path. For example, if I want to know the stresses or the deformation along one path, this is the way to do it. So you first go to your model, then you say construction geometry, then you click on path. So your path will be here. Then you can just choose your starting point and your end point. Then your path will be constructed. Then you will say solution along that path. So let me do this quickly. So if I want to know, say, for example, This is the reference, what's the coordinate system, and you also can do another coordinate system, for example, and then you can do the path from that from that coordinate system. Well, let's do this. So how to do a new coordinate system? I will show you now how to do a new coordinate system. So let's go to coordinate system and say coordinate system here. Then for geometry selection, so I will choose my coordinate system. I will go to defined by geometry selection. So I don't want it to be defined by geometry selection. If you want to be defined by geometry selection, you can just go and choose your geometry, but I want it to be relative uh, to my coordinate system. Okay, so I will say global coordinates, and it will be chosen for this. So if I want it to be, if I want my path to be along this line, along the y line, okay, I will just click on this, or I can just enter the value. So let's say along the x, it will be on the origin, and on the y, it will be also in the origin, but in the I'm so sorry, in the x it will be in the origin, in the z it will be in the origin, but in the y, let's say for example it will be for 3 inches. This is too much. Okay, let's say it will be for like 0.25 inches, or we can choose 1 inch. Okay, so now it's in the top. Okay, now let's say, so this is our new coordinate system. I will change its name. Instead of just coordinate system, let's say, for example, uh, rename, I'll say new coordinate system. Okay. Now let's go back to the path. Now we will define our path, and I will make it go from the origin coordinate system or the global coordinate system to the new coordinate system. And this will be easier to define our path. Okay, so I'll say from the global coordinate system right here, and it will be in relative to that coordinate system, it will be in the origin. So it will be exactly from that coordinate system. And this is the start point, and my end point will be the new coordinate system. So now our path is defined. Okay. So what if I want to know the deformation only on that path? So I will go again to solution. I will say results, then deformation, and total deformation. Okay. Instead of geometry selection, I will say path selection. Then I will choose my path. Okay. Then I will say, I will right click on this and will say evaluate all the results. So now it has evaluated the deformation results only on that path. So this could be helpful if someone wants to know the deformation or the stresses or the results along only one path. So let me just zoom in on this to see the results. So as you can see here, these are this is how my deformation on that path looks like, and here are the results. So I hope this session was helpful. Thank you for your patience, and I wish you all the best.